Welcome to the Deep Dive. We're here to really cut through the noise and pull out the essential knowledge for you.
That's the plan.
And today, our focus is sharp. We're looking at applying zero trust principles, specifically to critical infrastructure, the OT and ICS side of things.
A really critical area, no pun intended.
Right. We've gone through a whole stack of sources, articles, research notes, expert takes to kind of synthesize this down.
Yeah, there's a lot out there.
Our mission, really, is to give you a clear, insightful view of zero trust in this specific context. We want those aha moments, not just information overload.
And before we really jump in, let's thank our sponsor, www.CISOmarketplace.services. Their support really helps us do these deep dives.
Absolutely. Thanks to them. So guiding us today is our expert on this topic. Let's start with the big one. Why is securing critical infrastructure using zero trust? Why is it so vital? And I guess what makes it so different? I mean, the stakes seem incredibly high.
They really are. Think about it. National security, the economy, just day-to-day life. Critical infrastructure, energy, water, transport, you name it. It's the absolute backbone. And these systems, they're becoming more and more digital, more connected.
Which sounds like a good thing, but also
a huge vulnerability. The whole idea of an air gap, that these systems are totally isolated. That's largely a myth now. Business needs, efficiency drives, they demand connection.
So zero trust isn't just a nice to have anymore.
Not at all. It's essential. A successful attack here isn't just about losing data or money. It can impact public safety, national stability. The consequences can be, catastrophic.
Okay, let's get into the weeds a bit. What does zero trust actually mean when we're talking about CIOT, ICS? What's the core idea?
Right. The absolute core is never trust, always verify. Simple as that, but profound. It's a total shift from the old way, the castle and moat security.
Where once you were inside the walls, you were trusted.
Exactly. But today, with distributed systems, cloud connections, remote access, where are the walls? The perimeter's dissolved. So zero trust starts from the assumption that a breach might have already happened.
A pretty stark assumption.
It has to be. So every user, every device, every application, every connection, it needs to be continuously verified, authenticated, authorized again and again. Nothing gets a free pass. Every single packet, every asset is considered untrusted by default.
Okay, that makes sense conceptually. You mentioned it applies broadly cloud, on-prem, endpoints. How does that translate into the nitty-gritty of OP, ICS, and maybe even IoT devices within these critical systems?
Well, the beauty of zero trust principles is their flexibility. They're not just for your standard IT network. They absolutely apply to cloud environments, the servers in your own data center, laptops, phones, and critically, yes, to operational technology, industrial control systems, and the IoT devices that are increasingly part of that landscape.
So it's adaptable.
Highly adaptable. But it's important to see implementation as like climbing a mountain. You do it step by step based on risk, not a big bang approach.
Right.
And that incremental risk-based approach is absolutely vital in the CIOtics world, given how sensitive and frankly unique these environments are.
Okay, let's dig into that uniqueness. We're talking about systems that, interact with the physical world directly. Can you paint a clearer picture of what OT really covers and why securing it is so different from, say, securing a corporate database?
Sure. OT, operational technology, it's a broad term. It covers basically any programmable system or device that monitors or controls physical processes. Think industrial control systems, your SCADA, PLCs, DCS, but also building automation, transportation networks, even physical access control systems fall under it.
So a huge range.
Huge range. And CISA, the U.S. cybersecurity agency, identifies 16 critical infrastructure sectors. Things like energy, water, finance, healthcare, transport. The list goes on. Other countries might define it slightly differently, but the core elements are pretty universal.
And the big change is their connectivity.
That's a major factor. Historically, many of these systems were relatively isolated, the so-called air gap, but that's increasingly rare.
Why? What's driving the change?
Efficiency, optimization, remote monitoring, predictive maintenance, all the benefits of digital transformation. So you see OT systems connecting via embedded wireless, using cloud services, sometimes even SaaS applications, and even older legacy systems might connect indirectly, maybe through a maintenance laptop or shared storage.
Which creates pathways for threats.
Exactly. Add to that the fact that many OTC's environments rely heavily on legacy systems. We're talking old operating systems, maybe specialized hardware, proprietary protocols that weren't designed with security in mind and are incredibly difficult to patch or upgrade like you would standard IT kit.
And sometimes you don't even know what you have.
That's another huge challenge. Often, there isn't a complete, accurate inventory of all the OT assets. It's hard to protect what you don't know exists.
Okay, that really sets the stage for the unique challenges. So, beyond the sort of typical malware or phishing we hear about in IT, what are the specific threat vectors that keep CI security professionals up at night?
Oh, it's a diverse list. You've got the usual suspects, of course, but then layers on top. Regulatory pressures, for instance, can sometimes unintentionally create vulnerabilities if not implemented carefully.
Interesting.
Insider threats are a massive concern. Someone with legitimate access and knowledge, whether they're malicious or just make a mistake, the potential damage is huge.
Because they know the systems intimately.
Precisely. Then there's the supply chain. Compromised hardware or software introduced before it even gets installed. That's a nightmare scenario.
We don't even need to breach the network directly.
Right. And the impact of a disruption is so much higher. We're talking public safety, national security, economic stability. These systems are often interconnected too, so one failure can cascade through others.
A domino effect.
Yeah. And the motivations vary wildly. Economic gain, like ransomware hitting a pipeline, cyber espionage nation states wanting intel or disruption capabilities, political destabilization, outright cyber warfare.
And the older tech makes them easier targets sometimes.
Unfortunately, yes. Legacy tech often lacks basic security features. Plus, many OT assets are physically located in places that aren't like secure data centers, think substations, pumping stations. Physical access can be a vulnerability too.
So physical and cyber threats intertwine.
They do. And we're seeing a definite shift towards attacks designed specifically to disrupt or disable the control systems, not just steal data. Though it's worth remembering sometimes the simplest attacks, like social engineering, are still incredibly effective entry points.
It sounds like this convergence you mentioned, OT and IT coming together, is really pouring fuel on this fire.
It absolutely is.
Yeah.
Digital transformation, the drive for IoT, cloud integration, it's all about boosting productivity and gaining insights, which is great. But it inherently increases the attack surface.
Blurring the lines.
Exactly. That traditional air gap, if it ever truly existed, is vanishing fast. Remote access is needed, real-time monitoring from central locations, data analysis in the cloud. Industry 4.0 relies on this integration.
So what should IT and security folks really keep front of mind with this convergence?
Well, first, just the sheer pace of change. Technology is evolving fast, driving more connectivity. Second, the cascading effect, understand the dependencies between different critical systems. Third, the reality of OT-IT integration is here to stay, driven by solid business needs.
But Zero Trust can help manage this.
That's the key point. Zero Trust isn't just for brand new, secure by design systems. It provides a framework, a strategy to secure existing infrastructure too, the secure by retrofit challenge. It can bridge that gap.
That's crucial because you can't just rip and replace everything.
Yeah.
Okay, so as we look at securing these mixed OT-IT worlds, are there fundamental differences in, say, the goals or the basic architecture compared to traditional IT?
Oh, definitely. Big differences. In OTS, the absolute top priorities are resilience, uptime, and above all, safety. Physical safety, environmental safety.
Whereas IT often focuses on
the classic CIA triad. Confidentiality, integrity, availability. Often, confidentiality is paramount in IT. In OT, availability and integrity, ensuring the system runs correctly and continuously, are usually top, closely followed by safety. Any downtime, any incorrect operation can have immediate physical consequences.
So maintenance is tricky.
Very. Maintenance windows are often incredibly short and tightly controlled. You can't just roll out a patch whenever you like. New tech needs rigorous testing to ensure it won't impact safety or stability.
And the systems themselves are different.
Hugely. CI systems are often static, incredibly complex, very expensive, and they have long lifespans, decades sometimes. Frequently way beyond vendor support. Replacing them is a massive undertaking.
Not like replacing laptops every few years.
Not even close. And they often use proprietary protocols specific to industrial equipment, making updates and interoperability a challenge. Architecturally, you see loads of legacy systems. Old Windows versions, maybe no antivirus, sometimes direct internet connections someone rigged up years ago, plain text passwords. Yeah. And those unique industrial protocols, Modbus, Profibus, EMP3, they have their own quirks, varying implementations, limited patching options. Communication is often unencrypted because these protocols were designed for local, trusted networks, and adding encryption might introduce latency that the process can't tolerate.
So performance trumps security sometimes.
Historically, yes, or rather, operational necessity did. Then there's the physical exposure we mentioned. Monitoring is different too, historically focused on operational metrics, not security events. Collecting and correlating security data can be tough.
And the supply chain risk again.
Yes, OT suppliers often prioritize functionality and reliability over building in robust security from the start, though that is changing. Patching processes from vendors can be slower or less transparent than in IT. Plus other differences. The type of risk, safety, environmental, the sheer scale, geographically dispersed assets, the complexity systems controlling other systems, longevity, and often a mix of public and private ownership.
Wow, okay. That paints a very clear picture of why this is such a distinct challenge. So, faced with all this complexity, implementing zero trust can seem daunting. Where does an organization even start? I know there's a kind of standard 5-step process, often mentioned.
That's right. The NSTAC, the National Security Telecommunications Advisory Committee, laid out a pretty solid 5-step process. It provides a good architectural framework. The steps are: 1, define the protect surface. 2, map the transaction flows, though we'll adapt that term slightly for OT. 3, build a zero trust architecture. 4, create a zero trust policy. And 5, monitor and maintain the network.
Okay.
And this structure works well for CI audits because it supports that incremental, iterative approach we talk about, which is really necessary in these sensitive environments.
Right, let's break that down then. Step 1, defining the protect surface in OT. What does that actually involve?
Yeah.
That's fundamental.
It is absolutely fundamental. You need to know what you're protecting before you can protect it. So this means creating a really robust asset inventory, and ideally, not just a static list, but something dynamic that tracks what you have.
What kind of information needs to be in that inventory?
You need to classify assets based on how critical they are to the operation, the risks associated with them, and maybe even their current security and maturity level. This inventory is the bedrock for prioritizing your zero trust efforts.
Makes sense.
And it's often smart to use a crawl, walk, run approach. Start with defining protect surfaces around less critical systems, maybe pilots or learning zones, to figure out the process before you tackle the really high-risk stuff.
And protect surfaces in OT aren't just data.
Exactly. That's a key point. In OT, because it's cyber-physical, your protect surface often includes both digital and physical assets. We talk about identifying the DIES elements: data, applications, assets, and services.
Can you give some OT examples of those?
Sure. Data could be critical control signals, sensor readings, operational parameters. Applications might be your SCADA software, HMIs, engineering workstations. Assets are the physical things: PLCs, RTUs, sensors, network switches. And services could be things like essential network protocols, remote access services, time synchronization.
Okay, so DARS, how do you approach identifying these?
Often hierarchically. You might start with a high-level business process or operational system, break that down into its component subsystems, and then identify the specific DOS elements within each subsystem that need protecting.
You mentioned subsystems. Does this relate to any existing OT security frameworks people might be using?
Yes, very much so. The ICS 62443 standards are key here. They use a model based on zones and conduits. Zones are logical groupings of assets with similar security needs, essentially, your subsystems. Conduits are the communication paths between those zones.
Oh, okay.
So if an organization has already done work mapping out zones and conduits according to 62443, those zones are a natural starting point for defining your initial protect surfaces.
And this isn't a one-and-done task?
Definitely not. Defining the protect surface is iterative. You'll likely refine it as you learn more during the later steps. It's also important to see how DAIS relates to something like the CISO Zero Trust Maturity Model, the ZTMM. DAIS basically answers, what are we protecting? The ZTMM pillars, identity, devices, networks, etc. answer, how well are we protecting it?
Got it. So any practical tips for actually doing this definition in a real-world OT environment? It sounds challenging.
It can be. First, start with what you have. Leverage existing tools, documentation, network diagrams, even tribal knowledge. Don't wait for perfect data.
Good advice.
Identify all critical assets, anything essential for safe, reliable operation. Document their role. Use a business impact analysis, a BIA. Crucially, document dependencies. What talks to what? What relies on what?
Understand the connections.
Yes. Aim for a dynamic inventory, if possible, something that updates automatically or semi-automatically. Plan for ongoing updates. This isn't static. Use tools appropriate for OT. Standard IT scanners can sometimes disrupt sensitive OT equipment.
Need that OT expertise.
Absolutely. Collaboration between IT and OT teams is non-negotiable here. And finally, gather metadata for each protect surface data types, protocols used, criticality level. All that detail will be vital later.
Okay, that's a solid foundation. And just a reminder, this deep dive is made possible by our sponsor, www.sidomarketplace.services.
Thanks again to them.
Right, so we have our protect surface defined. Step 2 is mapping operational flows. You said we'd adapt the term from transaction flows. How does this work in OT?
Yeah, in OT, it's less about discrete transactions like in IT finance and more about continuous operational flows, process control flows, data streams. We need to understand how the system operates on a continuous basis.
So mapping how everything talks to everything else within and around the protect surface.
Precisely. Mapping the information flows to, from, and within that protect surface. Understanding how those DOS elements, data, apps, assets, services interact. This understanding tells you where you need to put your security controls.
And applying the zero trust lens here means?
It means treating every single connection point, every flow, as untrusted initially. Verify everything. This helps prevent lateral movement if something does get compromised, which is super important in these interconnected OT systems.
You need to understand the industrial process itself.
Having a good grasp of how PLCs, SCADA, DCS systems actually function and interact is definitely helpful here, yes.
And presumably that asset inventory from step 1 is pretty important here too.
Indispensable. It's the foundation. It tells you what assets are communicating, their functions, dependencies, communication needs, and actually mapping the flows often helps you refine that inventory. You might discover assets or connections you didn't know about.
Finding hidden pathways.
Exactly. And this is another place where that ISIE 62443 zone and conduit model comes back in. The conduits explicitly define the required communication paths between zones. That directly informs your segmentation strategy and what access rules you'll need later.
Can you give examples of typical conduits in OT?
Sure. You might have a plant-wide network, maybe using industrial Ethernet like OPC UA, dedicated control networks within a specific process area, field networks connecting sensors and actuators like Profibus or Modbus RTU, wireless networks like wireless HART, even old-school serial links between devices.
Lots of different types.
Yeah. And when mapping, you need to look at both the legitimate necessary flows and also consider potential unauthorized paths. Don't just look at what traffic is active right now. Think about what could happen.
Documenting everything is key, I assume.
Absolutely. Document the nature, the purpose, the data types, the protocols for every flow. This metadata is gold later on. And look for patterns. Maybe groups of assets always communicate in the same way. That can help simplify your architecture design.
We mentioned zones and conduits, but zero trust often talks about microsegmentation, getting really granular. How does that fit?
That's the ideal, really.
Wow.
While zones and conduits are a great starting point, especially in complex OT, the ultimate zero trust goal is to make the protect surface as small as possible, ideally down to individual assets or small groups. This allows for really tight, least privilege policies.
So moving beyond just zone boundaries.
Exactly. Maturing your ZT implementation means gaining the ability to control flows at a much more granular level. This really limits the blast radius if something goes wrong. Network segmentation is key architecturally, using things like DMZs between IT and OT. But we'll dig more into architecture next. One challenge here is that some older OT networks are quite flat, without many natural choke points for monitoring or control.
Making mapping harder.
Yeah, so sometimes you need to introduce managed switches, network sensors, or maybe software agents on devices that support them, just to get the visibility you need for accurate flow mapping, even if those aren't your final enforcement points.
And the disappearing air gap makes this mapping even more critical now.
Absolutely non-negotiable. When OT connects to IT, or even indirectly to the internet, you have to understand precisely how data flows between those worlds. Attack paths can come straight from IT into OT. This convergence, while good for business, can sometimes obscure exactly what's talking to what in the OT space. So meticulous mapping is vital. Watch out for undocumented connections or shadow IT type modifications too.
Sounds like a complex task. Are there tools or specific methods that can help with this flow mapping in OT?
Yes, thankfully. There are specialized tools from vendors like Dregos, Clarity, Nozomi Networks, Armis, and others. They often use passive network monitoring, sometimes combined with safe active polling designed specifically for OT protocols. They can discover assets and visualize the communication flows, which is a huge help.
So tech can assist.
Definitely. Many OT-aware firewalls also have visibility features, but tools aren't always feasible everywhere, maybe in highly regulated sectors or truly isolated networks. In those cases, you might use more analytical approaches, like mapping out critical functions and potential attack paths based on system design. Consequence-driven cyber-informed engineering, or CCE, is one such methodology.
A mix of approaches might be needed.
Often, yes. Tools, firewalls, manual documentation, maybe specific analytical frameworks. But honestly, the most important thing is collaboration. Getting OT engineers and IT security folks talking and sharing knowledge is crucial for accurate mapping. And meticulous documentation, keeping network diagrams, asset lists, flowcharts updated is absolutely essential for the long haul. And as we move into architecture, let's pause again to thank our sponsor, www.cisomarketplace.services. Their support is invaluable.
Indeed, thank you. Okay, so protect surface defined, flows mapped. Now, step 3, building a zero trust architecture for OTS. How do we use all that info to actually design the secure setup?
Right, this is where the planning really takes shape. You use the outputs from step 1, what to protect, and step 2, how it communicates, to figure out where to put your zero trust policy controls. It's strategic design.
Okay. You mentioned the Purdue model earlier. How does that fit in here?
The Purdue model is a useful way to visualize the different levels in a typical OT environment, from the enterprise network down to the sensors and actuators. It helps group assets. But it's important not to confuse it with the OSI model, which describes data communication layers. Here, we're focused on identifying policy enforcement points, or PPs.
TP.
Policy enforcement points. These are the places in your architecture, firewalls, switches, routers, agents on devices, where you will actually apply and enforce your zero trust rules.
Sounds straightforward for IT maybe, but OT.
Exactly. In OT, with all the headless devices, legacy systems, cyber-physical interactions, planning where and how to place effective PPs is much more complex and needs careful thought.
So visualizing this architecture is key, like drawing it out.
Absolutely critical. If you don't have an up-to-date, detailed diagram of your OT environment, creating one now is a top priority. It needs to show everything. Assets from step 1, the connections and flows from step 2, data classifications, business impact, protocols used, dependencies, everything.
Get it all on paper or screen.
Yes. And again, the ISA AEC 62443 Zone and Conduit Model is your friend here. It aligns perfectly with ZTA planning. If you've done 624443 work, you can leverage those zones, conduits, and security level assessments directly into your ZTA design.
How do those 62443 security zones relate directly to the protect surface concept in zero trust?
They're very closely related.
Yeah.
A 62443 security zone is effectively a type of protect surface. It's a group of assets sharing common security requirements. So once you've defined your day as protect surfaces and mapped the flows, you can group them into these zones.
Okay.
Ideally, in pure zero trust, each asset would be its own tiny protect surface or zone. But practically, especially when starting out in OT, you often begin by grouping assets into larger zones based on risk and function. You can always get more granular later as you mature.
Makes sense. And how does network segmentation, which you mentioned, fit into building the ZTA in OT?
Segmentation is fundamental to the architecture, and the 62443 Zone Conduit Model dictates where segmentation is needed. It shows you what needs to talk to what, and implicitly what shouldn't.
How is OT segmentation different from IT?
Well, a key goal in OT segmentation is often to prevent unrestricted jumps across multiple levels of the Purdue model. You don't want, say, direct remote access from the internet straight down to a controller deep in the process level.
You want controlled hops.
Exactly. Typically through carefully controlled zones like an ITOT DMZ. There are exceptions, of course, maybe for unidirectional data diodes sending data out for monitoring or specific purpose-built applications, but the principle is strict limitation between zones. ISIEC 62443 provides that vendor-neutral framework for planning the segmentation within your ZTA.
So when we're actually planning where to put these policy enforcement points, these PPPs, what are the practical things to consider in OT?
Several key things. Ease of operation and maintenance is huge. You don't want security controls that are too complex for the OT staff to manage. Flexibility is important too. The architecture needs to adapt. Redundancy is critical. You can't have a single firewall failure taking down a critical process. Think separate control and data planes where possible.
And placement.
The goal is always to get the PEP as close to the asset it's protecting as possible. For modern OT systems that can run software agents, putting the agent right on the endpoint is often ideal.
But for legacy stuff?
That's the challenge. For legacy, headless, or embedded devices down at level 1 or 0 of Purdue, you have to retrofit network-based enforcement. That means using OT-aware firewalls, secure routers, microsegmentation gateways, maybe unidirectional gateways placed strategically in the network path, operating at layer 2, 3, or sometimes 7.
Layer 3 versus layer 7.
Given the complexity and variety of OT protocols, Layer 3 policies based on IP addresses, ports, basic network rules are often more practical and less risky than Layer 7 deep packet inspection, which might struggle with proprietary protocols or introduce latency. So leverage your 62443 work, use agents where you can, plan network enforcement carefully for everything else, maybe even plan asset upgrades over time, and watch for emerging tech like secure device identities that might help with legacy gear eventually.
Okay, so that architectural planning sets us up for step 4, creating zero trust policy for OTISs. This sounds like where the rules actually get written.
Exactly. This is the first major doing step. You take the architecture you designed in step 3, and you start implementing the access control rules at those PPs you identified.
What's the guiding principle here?
Fine-tuning based on least privilege. Give users, devices, applications only the absolute minimum access they need to do their specific authorized job, nothing more, and review those rights regularly.
How does that translate into OT policy specifics?
It often means focusing on granular allow rules. Think back to the ISA 62443 conduits. You explicitly permit only the known necessary communication paths and protocols between specific assets or zones. Everything else is denied by default, especially at the boundaries between zones.
Deny by default at boundaries. What about within a zone?
That can be more nuanced. For safety-critical communications within a tightly controlled zone, you might have a more permissive allow-by-default stance internally, simply because incorrectly blocking a critical safety signal could be disastrous. It's a risk trade-off you have to evaluate carefully.
What are the main goals of ZT policy then?
Simplify management by focusing only on what should be allowed, rather than chasing every possible threat. And target your security monitoring and inspection on that known authorized traffic, because frankly, most breaches exploit legitimate, allowed pathways that weren't properly secured or monitored.
Okay, what are the key actions organizations need to take when actually writing these policies?
Right, several things. First, implement strong identity verification for users and devices. Multi-factor authentication wherever possible. But you have to balance the security rigor with operational needs. Can someone get emergency access quickly if needed? What's the safety impact?
Tricky balance.
It is. Second, write clear, comprehensive policy rules. Define the segmentation, enforce least privilege, mandate traffic inspection and logging where feasible without impacting performance, and make sure it aligns with any relevant CI standards or regulations.
What about tracking user activity?
That's the universal user follow-up idea, where systems support it, like modern Windows HMIs, monitor and audit individual user actions. For systems that don't have individual logins, like many PLCs, you need compensating controls. Strict configuration management, tightly controlled group accounts, strong physical access controls, maybe even cameras in sensitive areas.
Need different strategies for different tech.
Yes. Fourth, use decryption policies where you can and need to for visibility into traffic. Fifth, think about asset-specific security boundaries, putting tailored controls right next to your most critical assets, even beyond general network segmentation.
Like extra protection for the crown jewels.
Exactly. And finally, use the Kipling method. Ask who, what, when, where, why, and how for every access request.
How does that apply in OT?
Who needs access? Authorized users? Specific devices? What applications or data do they need? When do they need access? Normal hours? Emergency overrides? Where can they access from and where can they access to? Why do they need this access? Link it to a job function or operational need, and how should they access? Encrypted, specific protocols, via VPN with MFA. Asking these questions helps you build truly granular, context-aware policies.
That's a really structured way to think about policy. Okay, that brings us to the final step. Step 5, ongoing monitoring and maintenance in OTIS. This sounds like it never really ends.
It doesn't. It's absolutely crucial. Continuous monitoring and analysis are vital for detecting threats and responding effectively in CI. You need real-time visibility into network traffic, user behavior, device status, looking for anything anomalous or malicious. Regular security assessments, maybe penetration tests designed for OT are also key to find weaknesses proactively.
So what are the minimum must-haves for this ongoing process in an OT-ZT program?
Okay, minimum elements. First, specific incident response planning for OTIS. Get OT specialists involved, integrate it with your main ITIR plan, identify expert partners before you need them.
Don't wait for the crisis.
No.
Yeah.
Second, visibility and monitoring of OTIS. Identify your critical assets and data paths, figure out how you'll collect data using OT-aware tools like firewalls or specific monitoring platforms, and where you'll store and analyze it. Interestingly, OT networks can sometimes be quieter than IT networks, so anomalies might stand out more if you have the right visibility.
Okay, IR and visibility. What else?
Vulnerability management, but tailored for OT. The focus here is much more on contextual risk assessment and mitigating controls using your ZT policies, maybe network hiding techniques like SDP or SPA rather than just patching everything. Patching in OT is often risky and maybe only appropriate for a small percentage, like 4–10% of vulnerabilities found. You have to be very careful.
Patching isn't the default answer.
Often not. And finally, you need detailed, ongoing zero-trust architecture efforts. This means constantly looping back through the previous steps. Revisit step 1, have assets changed. Step 2, have access needs changed. Steps 3 and 4, can new tech improve our architecture or policies? And step 5 itself, are our IR, monitoring, and vulnerability processes effective? Review everything at least annually, ideally more often or continuously. Update your documentation religiously as part of change management. Reassess your tools and vendors periodically. It's a life cycle.
It really sounds like a continuous improvement loop. How does this whole zero trust strategy line up with other established OT security frameworks, like the SANS top 5 critical controls for ICS? Do they fit together?
They fit together very well. Zero trust strengthens those SANS controls. For example, SANS Control 1 is ICS incident response that aligns directly with ZT Step 5's monitoring and maintenance, especially the IR planning part.
Okay.
SANS Control 2 is defensible architecture. The entire ZT 5-step process is a prescriptive way to build that defensible architecture, emphasizing segmentation and mitigation, which is key in OT where patching is limited.
Makes sense.
SANS Control 3, ICS network visibility monitoring, is again right there in ZT Step 5, focusing on internal changes and configuration monitoring. SANS 4, secure remote access, is addressed throughout the ZT design and policy steps 1 to 4 and continuously monitored in Step 5.
And the last one, vulnerability management.
Right. SANS 5 is risk-based vulnerability management. Zero Trust enhances this massively. Step 2, mapping flows, gives you a deep understanding of data pathways. Steps 3 and 4, architecture and policy, implement segmentation and reduce complexity. This allows for more informed, risk-based decisions about patching, complementing it with strong mitigating controls enabled by ZT, and underpins it all with continuous monitoring from Step 5. It really reinforces that OT vulnerability management is different, less about patching everything, more about managing risk through architecture and controls.
So ZT provides a practical way to implement the principles in those controls. Now, we've talked a lot about retrofitting ZT onto existing systems, which is a huge task. What about new OT and ICS systems being deployed today? Is security being built in more?
Yes, definitely. While retrofitting is a major focus because of all the legacy gear out there, there's a very clear trend towards secure by design. Customers are demanding it, regulators are pushing for it, especially in CI.
So vendors are responding.
They are. Leading OT vendors and OEMs are increasingly embedding security features, many directly aligned with zero trust principles, into their new products and upgrades. Things like hardware root of trust, better device identity management, built-in ZT networking capabilities, continuous authentication options, native microsegmentation features, enhanced monitoring and logging. It's becoming part of the package.
Can you give examples?
Sure. Major players like Siemens, GE Vernova, Rockwell Automation, Schneider Electric, they're all actively incorporating these kinds of capabilities into their newer platforms and solutions.
So choosing the right vendor is important for ZT maturity.
It helps. Vendors with comprehensive portfolios who think about integration and security across their products will be better positioned to help organizations reach higher ZT maturity levels, like those defined in the CISO ZTMM. Using these modern, secure by design technologies can make implementing a robust ZTA more efficient and effective from the start. It helps you adapt faster to the threat landscape, too.
This has been incredibly insightful, really drilling down into the specifics of ZT for critical infrastructure. As we wrap up, what are the main takeaways you'd want our listeners to hold on to?
I think the biggest thing is that zero trust isn't just a buzzword. It's a vital strategy, maybe even an imperative now, for protecting CI against modern threats, especially with OT-IT convergence accelerating.
It's essential, not optional.
Pretty much. The 5-step process we walked through: define, protect surface, map flows, build architecture, create policy, monitor, maintain. It's a flexible roadmap. It works for new systems. It works for old systems. It helps you mitigate risk and build resilience.
But it's not just a tech problem.
Absolutely not. Success hinges on collaboration, getting cybersecurity, OT engineering, operations teams, and your vendors all working together, pulling in the same direction. And you need strong commitment from the top, from leadership.
What's the ultimate goal here?
The ultimate goal is safeguarding these essential systems that we all rely on. Protecting operations, ensuring safety, contributing to our collective security and economic well-being. It's about making things safer, more reliable, more resilient for everyone.
A really important mission. Thank you so much for sharing all this expertise today. It shed a lot of light on a complex but crucial topic.
My pleasure. Glad to discuss it.
And a final thank you to our sponsor, www.cisomarketplace.services, for supporting this deep dive.
Thank you.
And for you, our listener, here's a final thought to consider. Looking at your own organization's critical infrastructure, what's even one small element of the Zero Trust framework you could start exploring or implementing today? How can you take that first step to boost its long-term security and resilience? Remember, it's a journey, step by step, towards a much more secure future.